So we want to welcome you all to this program. So, like I said, this will be our final class. So we have two program. What's it called? Data sets. Then we have these gender, age, religion, resident, malaria status. Then what's it called? Then we have um, educational status, PCV, food blood counts, then total cholesterol level. Then for that of uh, BAD, then we have here we have age, sex, religion, education, food blood count, fasting blood sugar, total cholesterol, HIV status, then proteinemia. So I'm going to um uh, okay, this probably will be the one you will use for your assignment. So I will use the first one. I will use this one. Now, before I will go into the software, I'm going to recode. I'm going to recode this this what's it called? This data now, so that all these ones will have numbers. All these ones they will be numbers. So how do we do that? Now there are two ways you can do it direct from here. You copy this. Then on your computer, you do Control G. Control G.
Control G.
Sorry. No, that should be Control.
Hello.
Sorry,
Sorry,
can you hear
it's
me?
broken. No, can barely hear you. Well,
That should be from your end, though. Bide, is it breaking?
No, it's not.
It should be
all
your
right.
network.
In my network.
So now you click on Control F on your system. Then this thing will come. There's what we call find and replace. So this is replace now. Let's say we want to replace Christian.
So let's excuse sir, let's find out whether Flourish can still hear us very well.
Hello, Flourish, can you hear us? Hello, Flourish. This is our network. Hello, Flourish.
Hello.
Can you hear us?
Yeah, I can hear you now.
Okay.
Yes.
Okay.
So I said Control F. Then you have this. Then you copy what you want to replace. So Christian now, you put it under find. Then replace with 1. So wherever I see Christian, it will replace it with 1. So I have 29 placement for Christian. Then for Muslim, and come here, you also paste it. Then you say replace it with 2. But remember, I told you always
when you want to copy, you do the normal copy and paste.
Control C now.
Okay.
So you replace. So have that. So now the next one is primary. Primary is 1. Then degree. Say is 2. Now the next one is resident, urban, 1. So, rural. So which other one? This malaria status, the way it's coded, I don't know. We may have issue. So let me see whether. I think there's a new way of classifying malaria. Is there scanting again? All we have now is either 1 plus, 2 plus, 3 plus, and the likes. I don't think there's still scanty classification
Scanty.
again. Eh?
What we have now is like what we use where I work. We have observe, not observe. Then if it's observe, you now state the nature of the parastemia. So
So if the nature or the degree, I don't
the
think there's
degree,
any
sorry,
under
degree.
the degree. I don't think there's anything like a scanting again.
Uh,
It's either a
no,
plus, 2 plus, 3
okay.
plus.
Uh,
I don't know, Sha, depending on the system you are using. So
mm,
1. Abibide, is that your own?
Yes, in our own, there's nothing like scanty again.
okay.
Mm.
I know there's nothing like scanting again. So this is 11 now. You notice that wherever I see plus, he has taken it to be 11. So here,
Yeah.
so this 11 now, we'll replace it with 2.
Okay.
So I'm also going to replace counting with 1. So,
Okay. To be uniform.
but there's an issue. I'm coming now. I'm just trying to.
Okay.
You save. Then the next one I will do now is M. Now I will always advise, since it's just only one, always copy, especially this one that is just only one word. Copy it into another Excel sheet to do the transformation there. Because if you do, wherever I see M, it will change them. So this is M1, then F equals to 2. Let's copy and come and replace it. So that's all. Can you see it now? Huh?
Yes, sir. Yes, sir. Sir, maybe I may have forgotten. Maybe what was
Okay.
the reason why you are changing everything to numbers?
Remember, I told you there are some kind of analysis you want to do. That we are still going to convert them to
Okay.
what's it called? We are still going to convert them to the what?
Okay.
But we need to. this one. So now we have to open the software. So let's wait for the software to open.
Okay.
All right. So now we have to bring in our work into the sheet. So click here.
So how do you do it?
That file.
Okay,
How do I
file.
what?
How do you bring the work from Excel to this?
I've taught you before, but I will show you now. You click
Okay.
on file, you click on open, then you click
Okay.
on data.
Okay.
So you will now go to where you save it. Like my own now is on download. I downloaded it on download.
Okay.
Now you have to change this into Excel. Remember I told you have to change it to Excel. So once you change to Excel,
Okay.
all your Excel data will come. So this is it. Then you click on
Okay.
open. Then you click open. So that's it. So this one's
Yes.
So did you get that?
Yes, sir.
Yes, sir.
Now you notice that this one we are having this is how many decimal place like this? This is 1, 2, 3, 4. So we just want it to only be 2. So you come here
Okay.
and turn in to 2. Oh yeah, 1 7. Can you see it?
Where did you click first? Where did you
So
click
just
first?
click
Data
on
view. Variable view.
variable view. Variable view.
Okay. Okay.
So you come and change it. So
Okay.
now you come here now and come and check the measure. Are you with me? The
Where?
measure.
Yes.
I can't see the arrow.
You come here and check the kind of measure. I told you the other time that gender is a nominal variable. So you check whether is it a nominal. Are you with me?
Okay. Yes.
Now you check age. Age is continuous, so it will be scale. So it's correct. Are you with me?
Okay.
Now religion is nominal. Something you nominate, you represent them.
Yes.
It's not like you are giving number. So resident is
Yes.
also nominal, correct.
Nominal.
Malaria status is also nominal.
Nominal.
Computational status is also nominal. Hemoglobin concentration is scale because it's number. Fasting blood
Yes.
sugar is scale. Then total cholesterol is also scale
Scale.
because it's number. So that was why we check here to make sure that they are okay. Now the next thing that we are going to do now is to come now. Remember we said 1 in our under this place where we are coding it. That's why I told you you must always write down what you code them with
Right.
because
Yes. Yes.
now we said that 1 is male. Are you with me? And 2 is female. Please a minute.
Okay, sir.
Hello. So click
Hello, sir.
OK. Then
Hello?
age, we are not doing anything to age. Then under religion, we say 1 is Christian, then 2 is Muslim. So 1,
So where did you bring this thing? Is okay, still under variable view.
value. It's
Okay.
still under
Yeah.
variable view. Then you click on under it, then you click on value. Then 1
Okay.
is Christian, 2 is Muslim, let's see, then 1 is urban, 2 is rural. Malaria status. Would have actually be good that we first and foremost have positive, negative, but no problem. We just leave it as. We said 1 was 1 plus, and 2 was what? 2 pluses. So education. So 1 was primary, and 2 was. So once you finish, you come back. So can you see now?
Yes.
Flourish.
Yeah, I'm with you, sir.
So you can see what we've done. Now the next thing that we are going to do now is this age group. We are going to put them. We are going to create age group for it. Are you with me?
We are going to
Okay.
create.
Age group.
Age group.
Okay.
So now, how do you create age group? Remember the last time when I was teaching, before you create age group, the next thing you do is that you go first to go and check the minimum and the maximum value. How do you do that? You go to analyze descriptive statistics, then frequency. Are you with me? Then you
Yes.
move what you want to change into the variable. Then you select this. Then you come under statistics. Then you click on minimum and maximum. Then you click on that's just the only thing you do. You select this. Then you click on statistics, minimum and maximum. Then you click OK.
So come again. Hey.
I say you go to analyze. You go to
Right.
descriptive
Okay.
statistics. Click on frequency.
Okay.
Then you move it into whatever you want to what you want to change the maximum and minimum value for. You move
Okay.
it into variable. Then you deselect this display frequency table. It's usually like this, but you have to deselect it. Then you come to statistics. Then you click on minimum and maximum. Then you click on continue. Then you click on OK. So the result will come. So the minimum value is 15. The minimum age is 50, while the maximum age is 61. Are you with
It's
me?
one. Yes, sir.
So now, with this in mind, let's say we want to categorize our data into four let's say into 5 groups or 4 groups. So we have less or equals to 20 as one group. Then from 20 to 30, another group. Then from 30 to 40, another group. Then we have greater than 40 as the last group. Did you get that?
Yes, sir.
So Now, we've already written down what we want to do, but we need to go and tell the system to do the same. So let's go back to our work. Then you come here, you go to transform. You get me? Transform.
Transform.
Then under the
Yeah.
transform, yes,
Okay.
transform.
Okay.
Then you go to recode into different variable. Now you can say recode into same variable. I told you if you do that, it will change it. If there's any error, you will not be able to trace it. That's why you always recode into different variables. So you click that, then you move your age into here. Then you come here and put age underscore coded. Now here can be age group. But here there must not be space. I mentioned it. Then click on change.
Yeah.
Then you come here and click on old and new value. Now, remember we are dealing with range. If it was just one value, now you go ahead, but we are dealing with range. Now, the first one is between 50 and 20. So you say 0. We know there's no 0 there, but just say 0 to 20. So wherever you see 0 to 20, put 1 for us there. Then the next one is from 21 to 30. So 21 to 30 is 2. You add. Then 31 to 40 is what? 3. Then the last one is from 41 to 61 because it's 61 that is.
61.
Yes. So that is 4. You click on OK. Then you click on continue. Then you click on OK. So it will generate another data. You can see that it has generated another data for you. Can you see it? Can you see it?
Yes, I
Hello?
can see it. Yes.
Okay. So you come to variable view. Now let's make this one. We don't want any. Then under this variable too, you come and code. Remember we said 1 is between less or equal to 20. That's 1. Then we said 2 is between 31 to what? 21 to 30. And number 3 is 31 to 40. And number 4 is greater than 40. You get that?
Yes.
You click OK. And you complete. So you can see now. Now our data now is ready for analysis. So what we've done so far now is we've done coding, we've done data transformation. So our data is ready for analysis. Is that okay?
Yes.
Now, the first thing that we are going to do, like I told you guys, you go and do what we call data. You go and check if your data is what normally distributed. And the only data set you check normality for is continuous data. We check for age, we check for hematology, we check for blood group, fasting blood sugar, then we check for total cholesterol. But we know that automatically now we have changed this continuous data into nominal. Now, if you come now, you can see that it's nominal because we are now nominating age group. So now let's go. Let's go and do the normality test. You go to analyze, then you go to descriptive statistics, then you go to explore. Now, before we go, our hypothesis here is that the age group, hematology, BCV, fasting blood sugar, and cholesterol, total cholesterol are normal are normal distributor. Are normally they are normal distributed. That's the null hypothesis. Why the alternate hypothesis state that they are not normally distributed. Is that clear? So
Yes.
is those hypotheses now we want to go and test. Then you go to analyze, descriptive statistics, go to explore. Are you with me? So remove all of them, all what you want to check normality for, you move them into dependent list. Remove age into dependent list. Remove PCB, remove fasting blood sugar, then we move total cholesterol. Those are the 4 I want to check normality for. Then you come and say statistically. Now, this is okay. Now, remember, I told you, you must, under plot, you deselect this, leave, stem and leave. Then you click on histogram. Remember, we need histogram. Then you click on normality, plot with test. Deselect this. This one is selected by default. I mean, this stem and leave, but you deselect it. Then this one is deselect. So you select this, then you also select the normality plot with test. Then you click on OK. Then under this option, you are not changing anything. Now make sure that this display is both that is selected, because if it's not both, if you click on statistics, only statistics that will come, plot will not come. But here we need to see both the statistics and the plot to know the normality status of those data. Remember that when we are checking for normality status, we look at the histogram, we look at the box plot, then we look at the normality probability plot. Then we'll now look at the statistic, the two statistical tests, KS test and SW test. Is that okay?
Yes, sir.
So you click on OK. So once you click on OK, you wait a bit, then your results come. So have our results. So now this is our result. You can see that there is no missing result here. So we move to the next one. So these are our mean, median for each of the different tests. Then the next thing is the normality test. So you can see here that this age now already showed us that it's not normally distributed, because you can see that it's statistically significant. You cannot see?
Okay.
Hello?
You can see it now.
So you can see from here, the p-value here shows that there was a significant difference. So it means that they are not normally distributed. Based on this, then we'll move further to check whether is it true. Then for us to do, you select, you double click on the plot, you double click on this plot, then you come up, click on this particular, on this to bring this curve to it, because we need the curve to be able to interpret. So now this data is not normal, although it's tending towards normality, but it's not normally distributed. Because now if it was normal distributed, more should have been at this dome place. Now let's go further. You can also see that on this plot, on this normal QQ plot of age, you can see that if it was normally distributed, a lot of this data will be along this line. It will be along the line. Majority of these points will be at this line. So it shows that it's not normally distributed. So let's go further. Now, you can also see the box plot. It's not at the center, so it's not normally distributed. Then we'll move further. You can see hemoglobin, but the same thing. So you also double click here. So we will click here, then you close this, then you close this, automatically. Then also check. You can also check the same thing. It's not normally, because it's only 2 points that is actually at is on the is only 2 points that fall within this straight line. Then when you go to check normality, check the both blood, you see the same thing. Now glucose level the same thing. It's not also normally distributed. So you can see. So now you also see the both blood here. You can also see the both blood. Then let's go to the last one, which is the total cholesterol. No, in fact, it's not normally distributed. Same thing. So now when you have something like this in a normal circumstances, the kind of test you are supposed to run was what I run for you guys last week, which was non-parametric test. Now, because I need to also show you guys how to do t-test and the rest, we are going to assume that one of the data sets is normally distributed. Are you with me?
Yes.
Are you following me? So
Yes,
we
sir.
just assume that all the data set is normally distributed. So we are going to use it for both for parametric and non-parametric test. But in real sense, once you do your normality test and you notice that it's not normally distributed, then you know that you cannot run parametric analysis on that data set. Is that clear? Is that clear?
Not really, sir.
Hello? Not
Hello,
really,
sir.
like
Come
how?
again.
Which aspect, please?
What
I
you
said once
explained
you
last.
run your normality test, once you run your
Mm-hmm.
normality test, and your normality test shows that the data is not normally distributed, then you cannot run parametric analysis. And when I say parametric analysis, I mention parametric analysis are t-test, ANOVA, regression, correlation, and the rest. Are you with me?
Yes.
Why? So since it's not normally distributed, the normal statistic you are supposed to run is the non-parametric test, which is like your Whitney test, Cohort test, and all other tests that we'll see in non-parametric analysis. But I'm not saying for the sake of this training, we are going to assume that the data set is normally distributed, so that I will be able to show you how to actually do what's it called? How to actually do t-test, ANOVA, and the rest. So that's why we have to assume that it's normally distributed. Is that okay?
Yes, sir. Yes, sir.
So let's dive into it. Within the next 10-15 minutes, we are through with this class. So now let's go back to our data. Now remember I said for you to run a t-test, we've already concluded to run 2 tests, meaning you are comparing 2 groups. Are you with me?
Yes.
Yes.
You are comparing 2 groups. So like here now, we have almost all of them are 2 groups except this age group. So we want to check all these values based on, we'll just use one, let's say based on gender. So if you are checking based on gender, it's also like on religion, you are checking based on the resident. But let's just stick with gender for t-test. Why for the ANOVA, since this is more than 2 groups, no, for you to run ANOVA, it has to be 3 or more groups for you to run ANOVA. So now to run t-test, we want to check the cholesterol, all these different analytes, their level, their level based on gender. Are you with me?
Yes.
We want to check the PCV level based on gender. We want to check if there's significant difference between the PCV level of male compared to that of female, the glucose level of male compared to that of female, the total cholesterol level of male compared to that of female. So you come here, go to analyze, then you go to descriptive statistics, then you go to, no, sorry, here you go to compare mean, go to analyze, come to compare mean, then are you following? Analyze,
Yes.
click on analyze, click on
Mm-hmm.
compare mean, then you come here and select independent T test. Now, if it was just only one group, remember we said for you to do one group and over. Now let's start with this one test. Now let's assume we want to check this sample that you have established now. Let's say we want to check the PCV level of these people based on reference range, but we know that for male and female, they have different reference range, but we are just going to assume that the reference range is 40. Are you with me?
Yes.
Are you following? It's 40. So we come here, to click on one way and over. Then let's move PCV. there. Now, test value is 40. That's the reference, the known value that you are using to compare. Are you with me?
It's
Do you follow
echoing.
that? No? Is it
Hello.
echoing?
Yes.
Bide, is it echoing?
Okay, it's not echoing from my side.
Okay. Can you hear me now? Flourish.
It's echoing like.
It's still echoing.
Hello. No,
Yeah,
it
I
has
can
stopped
hear
now.
you. Okay. So
I said
let me recap
it
this.
has stopped.
And let me recap. I said if you want to do one way and only, click on analyze, click on compare me, then you come and click on one sample T test. Now you move what you want to analyze into the variable test. Then you type in your value, the value you are going to be comparing with. In this case, is 40. So here we come here and said, okay, we are not changing, it's 95% confidence interval we are running on. Then you click on OK. So once you click on OK, your result will come. So this is the result. Now you can see here, it's told us that we have 50 what? We have 50 samples. And this is the mean value. This is the mean 34.98. This is the standard deviation. This is the standard error of mean. Now this is the test. Now this is the T value.
Okay.
The T value is showing minus 10.086. The reason why you have this minus is because the T value, the test value was greater than the sample value. Did you get that? Remember the test value was 40. Then this mean value now is 34.9. So since the test value was greater than the sample value, that's why we are seeing minus here. Are you with me?
Yes.
Now, if the reverse was the case, it will not be minus. We will not see minus. It will be a positive value. So it's just showing us the direction. Now, this is the p-value, this sign two tail. Are you with me? This sign two tail is the t-value.
Yeah.
Do you get that? This is the p-value. So it shows that the p-value is 0.000. So it shows that there was a statistical difference. There was a statistical difference between the PCB value of our sample test and the reference value. Did you get that? There was a statistical significant difference between the test value and the reference value. Did you get that?
Yes.
Now let's move to two sample test. Now we are still going to use that. So to go to compare me, then here it will do independent t-test. Are you with me?
Yes.
Yeah.
Now we'll move the same PCB here. Now remember that is the gender we want to check. Then you move your gender under group variable. Are you with me?
Yes.
You move it under this group, then it will now ask you to state. So meaning that you must know what you use. Remember we use 1 and what and 2. That was what we use when we were coding. We say male was 1, then female was 1. So if you don't know those values, you may not be able to continue. So we also check everything is intact. So we click on OK. So you can see it has given us. Now you can see that it's telling us that we have 25 male, then we have 25 female. Are you with me?
Yes, sir.
Now the
Yes.
mean value of the male is 37.98, while the mean value of the female is 32.04. These are the standard deviation. Now this is the test, the t value. Now you can see here we have 10.894 here. So the reason is because the male value is greater than the female value. But if the female value was greater than the male value, you have negative value here. You get that?
Yes.
Now, this is the p value. This is the t value
Yeah.
that you usually see in papers and all of that. And this is the p value. So it also shows that there was a statistical differences between the mean hemoglobin, not mean PCV level of male subject compared to female subject. Is that okay?
Yes, sir.
So what I'm going to do, this data set that I code is the data I'm going to send back to you guys. Then what you people will do, no, I've used female now, I've used gender. Then you people will now use you use religion, you use urban, then you use I will show you the other one you use. Now we've done that. Then the next thing we want to look at is the ANOVA. Now remember that we said for you to run ANOVA, you must have more than 2 groups. Now this is one.
Yes.
We have 4 groups here. So
Two very.
hello, yes,
Yeah, I'm with you.
yeah. I said for you to run. Sorry, for you to run ANOVA, you must have more than 2. You must have more than 2 groups from 3 upward. And for this age group, we have more than 2. So it's fit for what we want to do. Then we'll come here, come to analyze. Then you come to compare me. Then you come to one way ANOVA. Now, remember that what we are working on is still PCV level. Then we'll now move age group under the factor. Are you with me?
Yes.
Now, I said you move your PCV under the dependent list. Then you move your age group under the factor list. Is that okay? Then you come here. There's what they call post hoc. Now, usually by default, it's usually SLG that they use most times. But if you are doing the work for a client, they might tell you to use any other one. But the most popular one is SLD or this portfolio. So you click that, then you click on OK. So once you do that, then we click on option, one descriptive, yes, one descriptive. So you click descriptive, then you click on the OK. So once you do that, you have the this is actually like the multiple list. You can see it will tell you I think the first one should be yes. So this one will show you, okay, how many were for we have 4 here, we have 21 here, we have 4 here, we have 21. So this is the mean value for this is the mean value for this age group, this is the mean value for this, then this is the mean value for this. That's the standard deviation, standard error at the end. So now we'll now go to this box is the ANOVA box. So this is what actually shows you. You can see that there was no statistical significant difference between the hemoglobin level within the age group, because here the p-value is not statistically significant. This is 0.401. For us to have a significant value, it must be what? Less than 0.05. Abi? Hello?
Hello, sir.
Hello?
Yes, I said for you to have a statistical value, a significant value rather, your p-value must be less than 0.05. Is that clear?
Yes.
So now, based on that, you can see that there was no statistical differences between the hemoglobin, the mean hemoglobin level across this age or between this age group. Is that okay? Now, for us to now check if there were differences from one age group or the other, that's when we use this what we call post-hoc test, which is also referred to as a multiple comparison test. Now, what this multiple comparison test do is that it will take the mean level of this group now, it will compare with this one, it will now check, is this significant? No. Then it will take the mean level of this one, it will compare with this, is this significant? No. If you take the mean level of this, you also compare it, is this significant? No. Now you can see now, the mean level of those that are less or equals to 20 compared to the mean level, the PCB mean level of those that are within 21 and 30, it was not statistically significant to this. This was 0.312. Now, when you also compare this with this group, it was not also significant. When you compare this with this, it was not also significant. So the next one is that it will not take this and compare to for us to check whether there will be any significant level. But you can see that there was no significant between any of the group. This is where you know. So you can see here, you can see that within here there is no significant difference among them. Can you see? Because none of them is less than 0.05. All of them are greater than 0.05. So is that clear? Hello?
Hello, sir.
Yes. So
Hello?
basically
Hello?
yes. Hello, Flourish. Can you hear
Yeah, I'm
me?
with you. My network is really disturbing me. Yes, sir, I can
Okay.
hear you.
All right. So I was saying that basically that's what you use this multiple comparison. So what I'm going to do now is that I think I will send you all the records of the training. Then I'll also
Okay.
send you all the PowerPoint. Then I will now send this particular this data set, this particular data set, this one. So you will do the same thing that I did. You can watch the video, then do the same thing that I did. But your whole analysis now, you will not be comparing age. You compare religion, you compare resident, then you compare malaria status, then an educational status. So you just do the analysis, then you save your work. How do you save your work? This output now, you save it. How do you save your output? You go to file, then click on save as, just the way you save your normal Word document. Is that okay?
Yes, sir.
Then you save. So you can save it wherever you want to save it. Then once you save it, then that's what you are going to you will bring it into the group. Then I will now review what you did. Then we now have the very last class. So let me see what you did. If you actually got what you are supposed to do. Is that okay?
Okay, sir.
But there is no rush.
Please, let me. What?
Okay. Go on.
Okay.
Flourish.
That's all. All right. You said we are to analyze educational status and what again?
What I'm saying is that you will compare. You know what I just did was only a methodological I used. Now you people will use. You can use either any of these data, any of these parameters. You can either compare the fasting blood sugar based on religion, based on resident, then based on malaria status. Are you with me? Or total cholesterol. Are you with me?
Yeah.
Then you compare total cholesterol based on
Yes.
religion, based on resident, based on malaria status, based on education, and based on age group. So I will send you put the video of this class. Then you attend to do what you do. Then I will give you people like a week to do whatever you have to do. A week. If you are able to finish it within a week, fine. Then meaning that we'll meet next Sunday to review. But if you're able to finish within, then maybe we'll meet either on Saturday or Sunday to complete. Is that okay? Hello?
Hello, sir.
Yes. So you can ask your question if
Hello?
there's any question. Yeah, go on. You can ask your question. Hello? Hello? Can you hear me?
I can hear you, sir.
Yeah.
Yes,
Ask your
I can hear
question.
you.
Ask your question. But did you get what I want you people to do?
Sir, please, once again, explain it very well for that assignment. I didn't really get it. So we should compare total cholesterol based on, or fasting blood sugar based on religion, age group.
Yes, just the way I compare the hemoglobin level based on gender.
Okay.
Yes. So what I want you people to do is to now compare. I don't want you people to do the same thing I did. It's the same thing. I don't want people to use the same parameter I run. That's why I say instead of comparing hemoglobin level with gender and age group, compare any of these parameters, whether fasting blood sugar or cholesterol,
Total cholesterol,
with
okay.
religion, resident, malaria status, and educational, whichever two of them that you can choose. You can either choose maybe religion and resident or religion and educational status. Then you also compare, you do ANOVA using compare either fasting blood sugar or total cholesterol based on age group. That's all. So is it clearer now?
Okay.
Is it clear? If it's not clear, I'll come back.
So I will come back, please.
I said compare. This is what I actually want you to do. I said go to analyze. Now, if you are doing, let's say you want to compare fasting blood sugar. So you go to compare me, independent test, and let's reset this. Then you move your fasting blood sugar into the test group. Then here you choose any other resident malaria, whichever that suits you. If it's resident that you want to use, you use it. After you have done that, you remove this. You use educational, you bring educational status into it. You also use. But you know that when you put, you must define what each of them mean. One mean this, two, one and two. Put one here. If you coded one, then you coded two. But if it's 01, whichever way you coded it, then you have to state it there. Is that okay?
Yes.
So that's just what I need you to do. Then you save
Mm.
your output and send it to the group. That's all.
Okay, sir.
Yeah. So just try your hand on it, because
How
if
are
you are
you?
just teaching, if you are doing teaching, and you are not trying your hand on it, you will not know, you will not be able to build your confidence. So go and make mistake
Yes.
and come back, then correct those mistakes. Is that okay?
Okay, sir.
Flourish.
We'll,
Alright.
we'll try
Uh,
our best.
So I will make
although it's not,
two exam.
it's not an excuse,
It's not what?
but I think I will try.
Yeah.
Hopefully together.
Oh, you say your system, you have not even got this system.
I have not got a system.
So basically we'll now reconverge when you are trying your hand on it. So good night. See you guys next week.
Okay, good night, sir.
Alright.
Thank you very much.